Okay, here is a quick video on section 3.7, absolute value equations and inequalities. This video is just going to cover the equations part of this section for right now. And we're going to start with a review definition of what is absolute value. So absolute value is symbolized by two straight lines on either side of a value or a variable or an expression. And it signifies the distance from zero. An absolute value is always positive because it represents a distance. So our example here, the absolute value of -6, again, those straight up and down lines on either side, that's telling you it's asking for the absolute value. The absolute value of -6 is 6. The absolute value of +6 is 6. Again, this is the distance from zero. So even if a value is negative on the inside of an absolute value symbol or the bars, when it is executed, when those absolute value bars are executed, the value will become positive. Notice that two different values, -6 and 6, can have the same absolute value. Again, two different values, -6 and 6, represent two different values, but their absolute value is the same, which is 6. That'll become very important here in a second when we're solving, okay? So, our next sheet. Now, we're going to look at example. This example is, you're being asked to solve the absolute value of x -6 equals 14. Now, I've promised you that solve is always going to mean the same thing, and it does. I want you to isolate the absolute value bars. In this case, that's easy because the x is the only thing inside them. You'll see in a minute that sometimes there's more inside the absolute value bars than just the variable. And even in those cases, you want to make sure that you only isolate the entire absolute value bars. Everything that's in them goes as one, okay? So here we're going to isolate the absolute value bars, and we're going to make sure we get a coefficient of 1 on the absolute value bars. So for our example here, we're going to add 6 to both sides in order to isolate it. And I get the absolute value of x is equal to 20. Now, the trick to absolute value is to realize that there are actually two values that x could have that result in an absolute value of 20. Think about that for a minute. There are two values I could put in for x that when I execute the absolute value would both give me a positive 20. So when we're solving absolute value equations, once we have solved for the absolute value bars, once we've isolated them and gotten a coefficient of 1 on them, our next step is to set up the positive solution and the negative solution. So what we're seeing is that absolute value equations can have two solutions. Okay, absolute value equations can have two solutions. The first is if what is inside the absolute value bar, in this case x, before that absolute value is executed, could equal -20, right? Because the absolute value of -20 is 20. Or x could also equal the positive solution, which is that x is already positive 20. Then when I execute the absolute value on it, it still remains positive 20. So once we have solved for the absolute value bars in these absolute value equations, we are going to set up both the negative and the positive solution. Okay? I usually put the negative solution to the left just because we're used to seeing those lower numbers on the left. The left of a number line is where our negatives are. Just makes sense. Put your negative to the left and your positive to the right. So let's look at another example. What if our problem is 4 times the absolute value of x equals 44? So first thing, notice that the 4 is outside the absolute value bars. There is no addition or subtraction sign. There's no fraction bar. So everybody should recognize that that is multiplication. So is absolute value bars, is the value inside the absolute value bars isolated? And the answer is yes. Nothing is being added or subtracted to the outside of those absolute value bars. Do the absolute value bars themselves, the value inside it, do the absolute value bars themselves have a coefficient of 1? No, they do not. 4 is the coefficient for those absolute value bars. That is what's being multiplied to the outside. So I still am solving. I need a coefficient of positive 1. I'm going to divide both sides by 4. And I'm left with the absolute value of x is equal to 11. Now that I've solved for the absolute value bars, those absolute value bars are isolated and have a coefficient of 1. I now set up my negative solution on the left. X could equal negative 11. And then I set up my absolute value positive solution on the right, which is x could already equal positive 11. Okay, last example for tonight. Here we're going to have to isolate and get a coefficient of 1. However, remember that when we do absolute value equations, we are isolating and getting a coefficient of 1 on the entire absolute value. So when we look at 3 times the absolute value of x minus 4 is equal to 36, are the absolute value bars isolated? Yes, they are. Even though there's that subtraction, it's inside the absolute value bars, and we cannot break those yet. We have to solve for them intact. So it is already isolated. Does it have a coefficient of 1? Do those absolute value bars have a coefficient of 1? No, they don't. 3 is there. It's being multiplied. So I need to divide both sides by 3. And I get the absolute value of x minus 4 is equal to 12. Have I solved for the absolute value bars? Yes, I have. They are isolated and they have a coefficient of 1. So now is where I split and I set up my two scenarios. On the left is my negative scenario. What is inside the absolute value bars, x minus 4, might actually equal negative 12. Or, on the right side, what's inside the absolute value bars, x minus 4, might actually already equal positive 12. So I solve each of these separately. For x minus 4 equals negative 12, I add 4 to both sides, and I get x equals negative 8. As with most every algebra problem we do, certainly with most every equation that we do, we can plug in our answer, and if we get a true statement, we know we did it correctly. So 3 times negative 8 minus 4, does that equal 36? Well, negative 8 minus 4 is negative 12, and the absolute value of negative 12 is positive 12. So 3 times positive 12 does equal 36. Check. On the right side, we add 4 to both sides, and we get x equals 16. We can plug that in. 3 times the absolute value of 16 minus 4, does that equal 36? Well, 16 minus 4 is 12. The absolute value of 12 is 12. And 3 times 12 does equal 36. Check. So, both of these are solutions for the x. In our original equation, 3 times the absolute value of x minus 4 equals 36. So, quick review. Absolute value is always positive because it represents the distance from 0. A value inside, if I have a variable inside absolute value bars, it can actually have 2 different values in order to get the same absolute value. Here, when we isolate and get a coefficient of 1 of our absolute values, we see that we may need to add or subtract anything that's outside the absolute values before we can split into a positive or negative solution. Again, we always have two possible solutions for an absolute value equation. If we need to get a coefficient of 1 because there's a value outside, we're going to divide just like we always did. If that was a fraction, if that 4 was a 1/2 times the absolute value of x, we would multiply both sides by the reciprocal, just like we do on our normal equations. Once we have solved for the absolute value itself, we split into our negative and positive options. Here, it was already isolated. We got a coefficient of 1. We split into our two negative and positive solutions, and we solved. Keep in mind, we have to keep the absolute value bars intact until we are ready to split into the positive and negative solutions. Tomorrow, after your review page that you're going to turn in to me, we will discuss what does it mean when we get no solution on an absolute value equation. We will also discuss absolute value inequalities. See you tomorrow.